Linear regression is one of the very first and basic machine learning algorithm. It tries to create a best fit line between the dependent variable and set of independent variables. It's the supervised machine learning algorithm. It requires some training data to train the model, followed by some testing data, that can be used to check the accuracy of the fitted model. As mentioned earlier, linear regression algorithm establishes a relationship between dependent variable and a set of independent variables. Dependent variable is the outcome or target or predicted variable. It is always bound by the values of independent variables, while independent variables are the set of variables that are used to predict the dependent variable. And linear regression is the algorithm that fits the dependent variable so as to predict the target. When the target depends upon a single independent variable only, it is called as univariate linear regression problem. However, when target depends upon multiple independent variables, it is called as multivariate linear regression problem. Here, a general equation of a linear regression algorithm is given. The value b0 is called as intercept, while b1, b2, b3 etc. are called as set of coefficients. Now, let's work out the linear regression algorithm by taking a numerical example. Please note that it's univariate example. Take the following data, where x is the independent variable and y is the dependent variable. A scatter plot between x and y is shown here, and here is the general linear regression equation between x and y is given. By calculating the values of b0 and b1, a best fit line as linear regression line can be plotted as shown here. Now, we will compute the values of b0 and b1 using the linear regression algorithm. Take a table as given here, and put the dependent variable x as in first column, marked as x. Similarly, put the dependent variable y in second column, marked as y. As a first step, find out the mean of x, and put in the respective column as shown. Same way, get the mean of y and put in the respective column as shown. In the next step, find out the difference between x and its mean and populate the respective column, as marked here. Same calculations are performed over y, and get the difference between y and its mean. The respective column is populated by y minus mean y, as marked here. In the next step, calculate the square of x minus mean of x, and fill out the respective column as marked in the table. Next, find the product of x minus mean x and y minus mean y, and fill the respective column as denoted in the table. This way, the entire table is compiled out and looks like as here. From the table, derive the sum of square of x minus mean x. Put this aside over here. Same way, get the sum of product of difference. Put this also aside over here. Now, take the general regression equation as y equal to b0 plus b1x. b1 is calculated by taking the ratio of sum of product to sum of squares as shown here. Hence, till now, b1 is computed out. Now, calculate b0. b0 is given by my minus b1x, and here is the b0 value. Hence, b0 and b1, both are computed out, and here is the desired linear regression equation. It can be stated that y is regressed over x using the given linear regression equation. Now, take the data set again to get the accuracy of the model. Take the linear regression equation as computed out here. Put the first value of x as 140 in the equation and get the y predicted value. Similarly, put x equal to 150, then x equal to 160, and x equal to 170, and finally x equal to 180. Now, take given y as true value, get the error as shown here. See the first error, second error, third error, fourth error, and the final error. Here are all errors compiled. Get the square of errors. First square error, second square error, third square error, fourth square error, and the final square error. And here is the complete error table. Take the sum of square of errors. Get the mean square error by taking mean of sum of square of errors. And finally get the root mean square error by taking the square root of mean square error.